Hello, everyone, and welcome to the Ronin Institute Public Seminar. If you're unfamiliar with Ronin Institute for Independent Scholarship, it's an institute that's dedicated to supporting high quality scholarship by independent and non-traditional scholars. So our aim is to build a more efficient and creative and humane model of academia. If you have any questions, you can write them in the chat box, or you can save them for the end of the talk when Greg will be taking questions. I'd like to remind you or point out, if you didn't already know, that this talk is being recorded, it will be posted on YouTube. We will turn the recording off at the end for the questions and answers. Okay, so our speaker today is Gregg Willcox. Gregg's been a Ronin for about a year now. In his other life, he's also the director of research and development at Unanimous AI, and he received his master's in robotics and BS in systems engineering from Washington University at St. Louis before he joined Unanimous AI. And he's the author of more than 30 papers and 2 patents issued in the field of swarm intelligence. And he's passionate about the intersection between complex systems and human-centric AI. We're very excited to have Gregg talking to us today, and he will be talking about human swarming towards better collective decision-making systems. Also you can learn about Gregg's research at his page on the Ronin Institute site, roninstitute.org/research/scholar/Gregg Willcox. And I think he has a pointer there to his blog. And finally, you can learn about the Ronin Institute at roninstitute.org. And if you want to contact us for seminars, you can contact at seminars@roninstitute.org. And as I said before, this is being recorded, and Ronin Public Seminars are posted on our YouTube channel, youtube.com/c/Ronin Institute. So without further ado, let's switch over to Gregg. I'm looking forward to this, Gregg.
Hi, thanks Varsha, and thanks everyone for coming. So my name is Gregg Willcox, and I'll be talking about human swarming and the tools that we've developed to allow us to make better decision-making systems in our daily life. So in the talk today, I'm going to bring you through my journey as a researcher with Unanimous, starting with the tool that we created, Swarm AI, and the research that we've done, and then broadening out into the theoretical underpinnings of real-time collective intelligence and the research that we're most excited about in the future. So really, this is a broad summary talk. Finally, we'll have the chance to swarm together for fun on some Ronin-specific questions, as I told you about, so you can experience the platform. I'll ask you to hold your questions until after the presentation, when we can go into Q&A, or post them in Slack or chat, either works. So let's start with talking about swarm intelligence. So what is it? Really, from our perspective, it starts with humans and human groups, and all the knowledge, wisdom, insights, and intuitions that humans have. We connect humans with real-time intelligence algorithms to form artificial experts. And this is the swarm intelligence process. And we find that the experts that are created through connecting people in real time, in this way, to collaborate and coordinate in synchrony, results in more accurate predictions, decisions, evaluations, and forecasts from the unified group. So how does it work? How do we actually do this? And this all goes back to the birds and the bees. And fish do it too, and ants are really good at it. And it's this beautiful process that is swarm intelligence. It's nature's evolved these ways to create real-time intelligent systems across a number of collective intelligence organisms. So this is really what we're referring to when we talk about natural swarm intelligence. So how does nature do it? Nature's evolved these methods for amplifying the intelligence of groups, but not by running polls, surveys, or focus groups, not by analyzing big data. Really, it does it by forming systems, like real-time systems, where the group is thinking together. These systems enable the group to converge on optimal solutions in real time. In fact, as a result of these systems, the group ends up smarter together than each individual were to be alone. And this is like, maybe you've heard of the collective intelligence, like common adage, which is like the sum of the parts, the whole is greater than the sum of the parts, right? And this is true in swarm intelligence as well. Swarm intelligence is fundamentally a collective intelligence phenomenon. So at Unanimous, we've been asking ourselves, can humans swarm? Can we take these natural properties of swarms, these things in nature, and make a system that humans can use to make better decisions in their everyday lives? So in doing so, we designed a system where participants can vary their choice and conviction in real time. Basically, what this means is there's a puck in the center, and each magnet is a user. And participants are trying to pull the puck towards an answer. And this slide will explain this a little bit better. Basically, there are two parts to this technology: a swarm interface and an AI engine. You can see a swarm happening in this lower left-hand corner. So each magnet is a user, and each user is trying to pull towards the answer that they think is best. In this case, we're predicting the Oscars, the best picture. And so you see here, there are 6 answers laid on the outside of the hex. The 2 that are most in contention are 3 billboards outside Ebbing, Missouri, and The Shape of Water. If you'd ask a poll, if you'd ask everyone just to say, what is the answer that you think is the most likely to win? The answer would have been 3 billboards outside of Ebbing, Missouri, by a small margin, right? So a poll would have resulted in that answer. But by allowing people to debate this in real time, using this magnet-based interface, this collective intelligence interface, that is swarm, we see that The Shape of Water results as the answer. The way it does this is because of this real-time communication between all of the participants and between this AI engine that we've developed. And really, this is a real-time communication, right? So the participants try to influence the puck, and then the AI engine moves the puck based on the behaviors of the participants. So if their participants are confident, they'll be given more weight than a participant that's switching very often and is clearly uncertain about the right answer. Right, so there's this, similar to how swarms work in nature, we've developed a real-time feedback loop that allows groups to converge upon optimal answers. Cool. So this is, so we've done a lot of research with this platform. We developed this platform, I think, 4 years ago before I joined, and we've been refining it ever since, conducting different research studies to evaluate how this system performs in the real world. So I'll talk about 3 of these studies here. The first one is Stanford Medical School. So we asked radiologists to diagnose pneumonia with this platform. And so there would be, in this case, 6 radiologists, or 6 to 8 radiologists in a room, each of them moving, trying to influence the puck to forecast the likelihood of pneumonia in an image. And in doing so, we found that they really significantly reduced their error in predicting pneumonia. So they made fewer errors. They were able to diagnose patients more accurately by up to 33%. We see this again with California Polytechnic. We did a subjective judgment test with 60 business teams. And this is basically an emotional intelligence test that was taken by groups that were working together for about a semester. And again, we see that even on this totally different domain, rather than forecasting a ground truth thing, we're now ground forecasting, for example, the subjective judgment or the emotion that a face is showing. Really interestingly, again, we see this error rate drop from individuals have a 32% error rate, crowds have a 26% error rate, so that's a voting system, majority vote, and the Swarm AI had a 15% error rate, so it's 52% improvement over individuals. More importantly, it's given the same people, if you take a vote with those people compared to a swarm of those people, you see the swarm outperforms the vote. So the swarm is better. And one of the big reasons that we believe this is the case is that the swarm allows the participants to like gauge their own confidence to behave in proportion to their confidence. So if you're in a minority and you're losing and the puck is sliding away, you have two choices. You can either entrench and you can say, I'm not going to give in. And you can really dig in and force the swarm to consider your choice more. And then sometimes the swarm does flip and the swarm goes to the initial minority faction, as you saw in the original example. Or, you know, if you're not confident about your answer, you flip and the swarm like goes quickly to the majority answer. So this system is really aggregating participant behavioral confidence, so the conviction that they have in their answers in real time. And this is why we think it's working, because it's really forming like essentially a natural swarm, like a collective intelligence system that's smarter than just taking a vote. We also predicted market indices. This is financial forecasting with a group of investors. And we predicted gold, crude, and SPX. And again, we see a significant improvement with the swarm over the individuals in the crowd. And we've done, I think, about 20 of these studies so far on a bunch of different domains. So what we found is that we were really quite confident that the swarms outperform votes. I think like we've rarely ever seen it be the case that the swarm performs at the same level as a crowd. So the point here that we're trying to get across is that like real-time systems for collective intelligence outperform voting methods. And so like specifically, we're excited about the Swarm AI tool because of this, because we've seen that it's able to actually make a difference in real world use cases for making better group decisions. So we've been applying it to a number of different like domains, from forecasting, so financial forecasting, to medical diagnosis, as we talked about, to like machine learning data set augmentation, so getting better ground truth data for training AI algorithms. But we've also done stuff like market research, from like evaluating how customers will respond to messaging, like resource allocation, crisis response. We worked with the UN to allocate food aid to different countries, depending on the like level of need, as perceived by a whole host of like experts gathered by the UN. We also like are really interesting about governance, and we did one study with Nesta on prioritization of like political objectives. So like, should the UK prioritize X or Y in a really polarized group? So we got together groups of like of Labour and Conservative in the UK context, and showed that like swarming was better than voting, the traditional voting system in that sense. And then also we're looking at education, so trying to reduce the impact of bias on learning outcomes by using Swarm as a classroom tool. So in this case, specifically reducing the STEM gap. So we know that Swarm works in some sense. We also know that we can apply it to a number of different domains. We're always looking to collaborate with people in academia, industry, and government to explore using Swarm in new spaces. So part of the reason for this talk is that if you have an idea for how we could work together, for example, like doing a study or publishing a paper, writing a grant, we want to talk about it. We want to like try to expand how we can like work with people in different industries and expand the utility of Swarm in these different spaces. Cool. So that is a summary of like where we're at so far. This is like a high-level summary of Swarm as a research tool. We've learned a lot from Swarm AI, and so the high-level takeaways are that like the smarter your participants, the smarter the swarm. So a swarm of experts is much smarter than a swarm of lay people because there's more intelligence to amplify. The more participants, the smarter the swarm, and also the more diverse perspectives, the better. Which really speaks to like this is true in other collective intelligence contexts as well. So in group decision making, there's been a lot of research on these facets as well. So the research that we've seen like holds true to these. So there are also two other takeaways that are specific maybe to Swarm AI, which is that participants really seem to buy into Swarm results, and they experience greater satisfaction from swarms than surveys. And I think these are really interesting from a, like both a research and a product perspective, because they allow, because if you're making a decision in a polarized group, or if you're making a decision collectively and you need participants to stand by it, you really want participants to feel like they were like a part of that discussion. You want them to feel like they've bought into the idea, which I think happens in Swarm because they've been engaged in this real-time feedback, right? They've been engaged in this, like if they were in a minority and the minority was losing, they still had a say in the, they still had choices that they were able to make in the swarm. And by entrenching, for example, and by holding out, they forced other people to work harder to drive more consensus in order to reach that answer. And so I don't know, I think these are two like really interesting facets of using swarm or swarm-like methods as decision-making tools. And I expect this holds beyond just the Swarm AI engine. Like I expect this holds for like real-time collective intelligence systems. Yeah. So I think it's also useful to think about in what other ways do humans swarm? And we've got one example here of a like graphic systems, which is like an example of real-time collaboration or swarming, where individuals are responding to one another in real time. I also think another really interesting aspect is discussion. And this isn't talked about very much as far as I've seen in literature and in different spaces. For me, discussion is really interesting because like if you and I are having a conversation, even if you're talking, I'm responding to you. I'm giving you non-verbal feedback, right? So my facial expression, my posture, everything is really directing the conversation in a way that we can find either agreement or disagreement or hash out what we need to like think about. To me, discussion is a really interesting version of swarming. Because of the amount of information that's like exchanged, and also because of the real-time like aspects of a discussion. And like, yes. So I think we can learn from discussions and how like they're so widely used in society and so useful. Also any form of collective action, whether it's like sports or like mobs or riots or any form of like movement in spaces is also interesting. And then also I'll bring up markets. Markets are very questionably swarms. And I'll say this because they're asynchronous and they're subject to like people who act first influence your actions. So they're asynchronous and they have like, people don't make independent decisions in markets, but they're still interesting in their application, the breadth of their scope. Cool. So sort of the thing that I want to take away from this are, how do we design better decision-making systems, right? How do we think about the next generation of collective decision-making systems? Let's say that we have to we want to move towards a governance system in which 1,000 people can like make good decisions together. Discussion doesn't really work for that. You know, if you have 1,000 people, you can't get them all to talk. You can't really, like, votes we've shown are less accurate than swarms. So I'm really motivated to start thinking about, how do we do this? You know, like, we have so many people, how do we get them to work together and reach reach good decisions together that they A, all feel good about, and B, that actually that make positive impacts on the world. So this is hard, right? This is a challenge that is not going to be solved immediately. And so we're just starting down this research path of how do we make inroads into this question. So I just want to list a couple desirable properties of swarming mechanisms from my own experience so far, to motivate a search for how do we find systems that allow us collectively as a society to have better decision-making systems. So the first that I think is valuable is maximal information exchange. I think the more that we're able to share with one another in terms of information, why do you think this? Motivate your decision, yeah, exactly. Why do you believe this thing? I think that is helpful in collective decision-making because it allows me to empathize with your view. It allows me to, if you share a story with me about how a policy has impacted you, it allows me to better understand the implications of whatever decision we're making on your life or on different people. I think that independent and synchronous judgments are really valuable. Like we said, markets show these bubble phenomena, partially because they're not synchronous, they're asynchronous. Everyone is not everyone in a market is participating at the same time. And the valuation of a commodity is dependent on the valuations of it the commodity before that time step, right? So this is one of the reasons that I think swarms are better than markets in many respects, because they are independent and synchronous rather than dependent and asynchronous. And so they will get, I believe, more accurate answers at any given times point than a market type thing. I also think that synchronous communication is valuable. And I say this because there's a lot of research showing that the loudest voice in a room in a discussion will dominate. And that's partly because they're outweighted in terms of like their influence, both because they're the loudest and because they're talking first and the most. A lot of research, or some research in collective intelligence or in group decision-making contexts, have shown that the more that this, oh geez, can you still see my screen? Is everyone there? Cool. This research has shown that the more that speaking turns are evenly distributed throughout the group, the higher the group intelligence. So the higher the group is able to perform, the more accurate they're able to perform on tasks. So I think this really speaks to, we want a system where individuals can communicate and like coordinate in synchrony rather than like each taking turns. And I think this helps to scale the system to thousands of users. I also think it's important to allow members to feel safe in the space. Again, group intelligence research has shown that if you feel safe in expressing a dissenting view, and I think Swarm enables this, but maybe our governmental systems don't, then like that leads to better group decisions and higher group intelligence. And then also, I think that it's important for experts to be given a higher priority, either by behaviorally expressing a higher confidence, or just by like swarming with a group of experts, or like upweighting those experts. We've done a bit of research on self-reporting. So is it worthwhile to say, hi, I'm an expert? The answer is not so useful. If you asked people how confident they are in their forecast, and weight by that in any, like tried a bunch of different weighting schemes, it consistently performs worse than a swarm, right? So self-reporting is less accurate than behavioral expressions of reporting. People believe that they're an expert, but when you put them in the swarm and they're in a minority, they'll switch pretty quickly some of the time, right? So we find that like behavioral expressions, if you're actually like acting on information or acting on your level of confidence, that mechanism of reporting confidence is significantly more accurate than self-reporting confidence. So maybe that was a little scattershot. I just wanted to throw out some of the things that we've learned from swarms and touch on a couple of different effects that we've observed in practice. So again, to me, the most exciting future directions are those that work towards building tools that allow groups to make better decisions. So this really means engaging the whole group in making decisions rather than just the loudest voice in the room. It also means increasing the buy-in of each member and creating spaces that foster meaningful exchange of information. So like, I really want to work towards collective intelligence as a tool for future like group decision-making. And I'm excited to like collaborate with all of you and with Unanimous in doing so. I'll share as a final point some of the directions that we're taking to work towards this point, which are like, one thing that we're developing is a slider swarm, which is a real-time interface that allows people to like give estimations of probability to events, which a discrete binned application like the hex swarm that you see and that we'll participate in later doesn't really allow. This also allows us to, for example, run stuff asynchronously potentially, as well as to like create local groups where like a confident minority can overcome a confident majority or unconfident majority, which I think is potentially very helpful. The other thing that we're really trying to build in is discussion swarms. And we've seen this be useful previously. What I mean by this is swarm, discussion swarm, or discussing while a swarm is going on. We've seen this be really useful in the UN study that we did. So the UN had to get together a group of experts from a number of different domains, and they weren't used to collaborating together. They weren't used to talking together. And so they observed that the groups had a really hard time getting good answers at the start if they were just swarming. But then they introduced a methodology that was swarming and then discussing about the swarm, or like reflecting on why do you think the answer is this, or why do you disagree or agree with this answer? And engaging informationally and logically with each other, and then swarming one more time to reflect the discussion that they just had. And they found that that gave them qualitatively much better answers or much deeper insights into the beliefs of their group, and had a higher level of cohesion. So yeah, so I'm excited about building in more informational or logical information exchange into these swarming systems, and also like looking into like enabling more people to swarm in a asynchronous context. So that's it for this part of the talk. We have, what time is it? Sweet. Okay, we have a lot of time. So let's head to our demo. This will take about 15 minutes to prioritize Ronin objectives. Okay, so we'll send this link over the Zoom chat so you can join the swarm and enter a username. If you want to stay anonymous, just enter anonymous or a random string of letters and numbers. You don't have to use your real name. Also, if you're not, if you don't want to join, or if you like are doing something else on the side, that's totally okay. I'll be sharing my screen, so you'll be able to see what's happening. Though I do recommend participating because it's a totally different experience. It's pretty fun. I will wait for everyone to join, and then I will start posting these questions. So yeah, just while everyone's joining, I think we have, how many people are on this call? 31, okay. So I'll wait till about 25 or 27 people. I'll wait a couple more minutes for everyone to join. While you're waiting, you can start playing with the puck. So move your magnet close to the puck. You have more influence the closer your magnet is to the puck. You want to keep it close, and you want to point towards the answer that you want. So if you like, maybe let's all try pulling towards yes at the top. There you go. Yeah, perfect. So yeah, the closer your magnet is, the better. And I'll start bringing this stuff in. Cool. So I'll read these chat bubbles out as I pop them into the platform. So you're logged into Unanimous AI's Swarm AI platform. Today, we'll combine your input with Swarm AI to gather insights on the most important objectives for the Ronin Institute. When you put your mouse next to the spinning puck, it turns into a magnet. Your magnet is green, everyone else is gold. Use your magnet to pull on the puck. I'm going to present some questions in just a minute, and we'll all work together to answer the questions by pulling the puck to an answer. Pull for your first choice, but be open to compromise so that an answer is arrived at in time. The closer your magnet is to the puck, the stronger your pull. Keep in mind, you need to pull continuously with your magnet during each answer. If you're not close to the puck, you have little influence on the outcome of the question. Our goal is to converge on the best possible answer for each question by combining the knowledge, wisdom, insights, and intuition of the full group. Let's do a warm-up question to make sure everyone knows how to move the puck. So we're going to be asking, for what did Albert Einstein win the Nobel Prize? Nice. That's actually the right answer. Good work. Cool. So remember to position your magnet during the 3, 2, 1 countdown so that your preference is registered from the beginning. Also, remember to reposition your magnet as the puck moves. You don't need to click, swipe, or drag for your preference to be registered. So are there any questions about how to use this platform to answer questions? You can type in the chat in the Swarm interface, or you can type in the Zoom chat. I'll give it just a minute. Yeah, looks like we're okay. Cool. So let's consider some goals for the Ronin Institute now. As many of you know, the Ronin Institute is devoted to facilitating and promoting scholarly research outside traditional academic research institutions. So today we want to prioritize the most important specific goals for the Ronin Institute. Think of this as a high-level planning question. What should the Ronin Institute do to best facilitate and promote scholarly research outside of traditional academic institutions? So give me just 1 second while I bring in the new answers from the discussion earlier, and then we'll swarm on this. Okay, so we're going to run this as a process of elimination. So we'll start with the least important goal for the Ronin Institute, and then we'll eliminate answers until we get to the most important goal. So I'll ask this question now. And just remember, the closer your magnet is, the more influence you have. So the closer your magnet is to the puck. So and remember, this is going to be a process of elimination. So we're trying to find the answer that best represents the interests of the Ronin Institute. You may not be the interests that are personally best for you, but represent the Institute's members the best. Okay, so this is what we call a brain freeze. This happens pretty rarely, but I guess this is a tough question. Let's try that again. And remember to be open to compromise. I saw a lot of switching there, which is good. We just want to find the answer that best represents the Ronin Institute itself.
So Greg, I might suggest that, I mean, you have this 3, 2, 1 countdown, but it doesn't entirely seem like enough time even to read all the options.
Okay, my bad. Yeah, I should have posted these actually before we started. Let's try that again. Hopefully everyone has had time through the last form to read these answers. Cool. And now we're just going to repeat the same question, but with that answer removed. Great job finding compromise, everyone.
Maybe this one just likes that top right.
Cool. Cool. Last 2 questions. Cool, nice work, everyone. Okay, so this is our last question, and we're gonna do so this is an AB question, and we use by a little and by a lot just to give a sense of degree of confidence. Again, this is the least important goal. Cool, folks. Nice work. So that means that improving funding access is, according to us, the most important goal for the Ronin Institute. Good job working through that, especially with the brain freeze at the start. I think after the call, I'll send out a little, or at least to the Ronin Institute folks, I'll send out a little graph with some insights from this. Yeah, and I think now is an appropriate time to open this up to questions.